All right, welcome back to another update for Cultist Astronaut. Today we're looking at the Unity side to start with to explain, the depth and sorting concepts, and then how those are going to translate over to our engine, and then what we have so far in our custom engine. So in Unity with sprites, you can change basically the way they render by tweaking the sorting layer and the ordering layer, which we make heavy use of these in our game in order to get everything layered correctly. It's very rare that we change the Z value, and we might be changing it in some places, but if I was to go into like the 3D view, you'll see this is pretty much as flat as it gets. And that is because we are primarily using the sorting layer and ordering layer properties. Now in Unity, I believe you can switch it over to use the Z value, but by default, if I just change, if I go back into this and I grab, let's see, the background. You see here, this is the background. I can pull the background forward and backward, but you'll see it never renders above the other tiles. Now it does render correctly in 3D, but if I go back into 2D view, you'll see that everything is still correctly as is rendered correctly as you see here. Maybe we can use a different tile map as a better example, like the ground. Like I can move the ground, backwards and forward, and it looks like that actually does affect it there with. Let me try that one more time here. It does look like that actually does have an effect in here, but that might be because it's too far away. That's actually really interesting. Let me see here if I pull this back in. Oh, I'm going too far. Let's go this way. Oh, so the reason why that happens is because we're pulling it outside of the range of the camera. So Z does have an effect on the camera. So that's like barely within range. So if I go back into 2D, the ground's there, but if I go like to -11, you'll see it's no longer rendered, whereas -9 is rendered and then 0. So obviously Z is useful for those types of things, but generally everything is being sorted by the sorting layer and the order in layer, which you can see on each one of these we set it up to be a specific value. Now we're exporting these from Unity into our own file. So I have a tool up here called Export World, which allows me to export all of this information to a file. So if you look here, we have our data folder in our custom engine. And if I open up the Excoria world file, you'll see that we have defined the sorting layer and the sorting order in this exact file. And these correspond to the same layers that we saw in Unity. So if I go to here, you'll see we have a characters layer, projectiles, items, etc. What we have done is we've exported these to our own sorting layer config file. So you can see here. You can see that 4 is actually a character, is on the character layer. It's not necessarily a character, but it's being rendered on the character sorting layer. And so this is the sorting layers config file that we load into the editor. This allows the designer to pick and choose what sorting layers they want for their sprite or for their character. And then that, of course, gets saved into the entity, specifically on the, if I go back to this file, it gets saved specifically on the sprite component. We also handle this for tile maps. So if I go to the this is the room wasteland 00 ruin tower. This is actually what we see here, but it's been exported to our own file format. And you can see right here we actually have the sorting layer 3 1000. And if we take a look at tile map start, or not tile map start, but background BG 1000, -1000, and we go to that exact layer here, you'll see it uses the background layer and -1000. In our file, that's encoded as an ID, so we're using sorting layer 3, and sorting layer 3 lines up with background. So everything is correctly exporting. And then what we do on the engine side, let me open this up here. Let me go to my other file because it's a little easier for me to navigate. What we do over here when we render the game, this is our render loop. We do all the typical stuff like clear the back buffer, set up the topology and all of that, the blend state, that's important. And then what we do is we submit all of these renderers to a concept called the render item system. Now, render items are a way for us to basically say, hey, these are all the things I would like to render, right? Here's their sorting layers, their sorting orders, and then here's some information about what it is we're rendering. So if in the case of this, we're rendering the player, and we're telling it, hey, it's a spine, and it has this direction, has this position, and it uses this renderer information. And we do the same for tile maps, right? When we loop over all the tile maps that are being rendered in the game, we submit all of this to the render item component. And again, we set up the sorting layer, the orders, and the type, and then we pass in specific information that we need in order to render that. So in this case, we give it a pointer to a tile instance array, and then we tell it how many from that point. So we have a base pointer, and then we have the count that tells us how far into that pointer we should go when rendering the tiles. And this is using instancing, so basically every tile map you see, or every tile map layer you see, is rendered in one draw call. And we do that by packing everything into this tile instance array, and then that's not packaged, but sent off to the GPU. And then of course we do the same thing for sprites. So you can see we have a specific type for sprite, and again there's that sorting layer and there's that sorting order. So every render item has these three things, and then you can specialize into specific types. And we covered this in our previous video, but we're using a union to accomplish that. So basically, when we create a render item, we can pick its type, and then we can set values in its specific container. And since we're using a union, this doesn't take up 3 times the space, right? It's not taking up the space for all 3 of these. It's only taking up the space for the largest one, and then it's treating that block of memory as if it's a tile map or a sprite or a spine object. And you can see here, this is all the data we need to render a sprite, tile map, and spine renderer using using the render item system. So once we package everything into the render items, what we do is we call a sort function. And right now I'm just using the standard library. I'm thinking about changing this, of course. I should probably add a comment here. Let's see, write custom sort. The reason why I would build a custom sort is because it's more efficient. Right now I'm just kind of using like C++'s standard sort solution, which isn't going to be optimized for the kind of sorting I want to do. But anyway, this is working for us for now. And basically, if the sorting layers are the same, then we compare the sorting order. And if not, then we just check the layer. And so that should be pretty good. And this basically takes the render items that we've packaged together and reshuffles them so that they're in a back to front order. So when we render these, we want the objects further away to be rendered first, and then as we pull forward, right, we're going to render objects on top of that. And the reason we do this is because most sprites, almost all of the sprites, are quads, but they use a texture that has alpha. Meaning that, like for example, if we go into Unity and we take a look at this like mountain here, you can see it's a quad, but this texture is not fully opaque. It has alpha. And so we have to treat this as a transparent object when we render it in, well, DirectX or OpenGL. If we treat this as an opaque object and we just use the depth buffer provided by Unity, we'll end up with artifacts where things cannot render behind this empty space because the depth buffer thinks this is a solid. And so instead what we do is we don't write to the depth buffer at all, and we just render back to front. Now this can break batching in some cases, but there are ways around it. And as you saw with tile map, I'm still batching tile rendering in a way, right? I'm not doing all the tile maps together like I was, but when I render a tile map layer, I am batching the tiles. And you know, there's still some room for improvement here. So when I come down here to render a sprite, I'm still not batching my sprites as well as I could. Right now I'm kind of just like looping through all of the sprites, and I'm saying, okay, render it with this texture view. And there might be 100 objects that use the same texture view. So instead of calling this function 100 times, which is expensive because we're updating some value on the GPU, we update it once and then we render 100 sprites. So that's what I mean by adding batching support. So this might evolve so that we can batch things more efficiently. And I can even batch things in such a way where we can send multiple textures, and then we send a buffer full of quads, and then we have information about how to assign those textures to those quads, etc. And then we do one draw call for, you know, 10,000 quads as an example. And that would be a really efficient way of rendering this. And even for tile maps, instead of treating tile maps as individual tiles that we have to like instance together, we can combine and merge them into one giant piece of geometry and then render that. But if we come into our editor here and we run it, you'll see that it's actually running pretty well right now. Like for what it is, like this is running pretty smooth. And you can see we have most of the objects imported correctly. And just to get a side-by-side here, let me open up Unity here and just show you. So there are some differences, of course. Can I do this? Let me try this out. I don't think I can resize my window, but you know, we can at least try to get it side by side here. So you'll see that yeah, this is pretty much what you see one for one. The only big difference here is, like, you can see the pillars aren't fully scaled up to match what we have here, and that's because we don't have support for tiled draw mode sprite renderers. So if I was to switch this to simple, and I set this to, let's see, 1, would this be correct? I think that's too big. It's close, but it's not quite right. But yeah, you get the point. This is not using the draw mode that we have set here, so that needs to be considered. And then of course we are missing the same thing for these objects, for the walls. These are tiled sprites. We don't have animated tiles, so like you'll see the top layer of this pool is missing. So we'll need to have support for tiled or for animated tiles. And then yeah, but in general this is working. I think that covers what has been done today. I spawn inside the wall, so that's not good. But you can see I can run around this, and it has collision, and all the sprites are being exported correctly from Unity. There's a couple things that we can't collide with, like this isn't a collidable. But the cool thing is you can see the layering is working perfectly. Like I can run behind the legs of this walker, which is how we've had it implemented in Unity. Yeah, so that's my update for today. Yeah, as always, let me know if you have any questions or feedback for the game. Have a great day.